Yeah. Good evening, children. Good evening, online students.
Good evening, Mom.
Good evening. My presentation is visible.
Good evening, ma'am.
Good evening.
Yes, ma'am.
Yeah.
Yes, ma'am.
So, of this chapter, quadrilaterals, we understood the examples before exercise 8.2, and also we have discussed the proofs to all the questions in exercise 8.2. So 8.2 and before 8.2, the examples we finished. Now this is the same chapter, quadrilaterals. Examples before 8.1 and exercise 8.1 today. All right. Now show that each angle of a rectangle is a right angle. Show that each angle of a rectangle is a right angle. All right. So the given quadrilateral is a rectangle. It's given it's a rectangle. You don't have to prove it's a rectangle. Show that each angle of a rectangle. So what quadrilateral should you consider? You should consider a rectangle. But what should you prove in that? You must prove that each angle is a right angle. Okay, so you're given a rectangle. You're given a rectangle. You'll have to prove that each angle in a rectangle is a right angle. Now you will say, it's so funny. It's a rectangle, then we know no, every angle is a right angle. That's what you have to prove. Since we know this property of a rectangle right from 3rd standard or 4th standard, the statement might be funny. They've given it a rectangle and they want us to show that every corner is a right angle. Because you know this property for a very long time. So it's like, might sound a little, funny, but that property is what you'll have to justify. Okay, prove using congruency or some other property or properties. So take up a quadrilateral, which is a rectangle. Okay. Okay, so you're given a quadrilateral ABCD, which is a rectangle. What is the definition of a rectangle? It's a parallelogram. A rectangle is a parallelogram. That's a definition. A rectangle is a parallelogram in which one angle is a right angle. So it's a parallelogram. So opposite sides are parallel. A rectangle is a parallelogram in which one angle is a right angle. By the definition, if now in 9th standard in this chapter, when we say rectangle, the definition of a rectangle is it is a parallelogram in which one angle is 90 degrees. That's a definition. So if ABCD is a rectangle, it's a parallelogram in which any one angle is a right angle. Now, so we know one angle is 90. So we have to prove that the remaining are also 90. We know that D is 90 by the definition, or A is 90, B is 90, any one is 90 by the definition. Now you'll have to show that the rest of the angles are also 90. Use the property of a parallelogram. In a parallelogram, opposite angles are equal. Therefore, angle B is 90 because it's a parallelogram. And what's the property of a parallelogram? In a parallelogram, opposite angles, both the pairs of opposite angles are equal. So if D is 90, B is also 90. Now it's a parallelogram. Adjacent angles are supplementary. It's a parallelogram, so adjacent angles are supplementary. All right, so angle D plus angle C is equal to 180. Adjacent angles are supplementary. You can say D plus C is 180, or you can say B plus C is also 180. You can say B plus C is also 180, anything. Or you can say B plus A is 180. B plus A is 180. Adjacent angles are supplementary. A and B are adjacent angles. Next angles. A, B, C, D. A and B are adjacent angles. B and C are adjacent angles. C and D are adjacent angles. D and A are adjacent angles. What are opposite angles? A, B, C, D. A and C are opposite angles. B and D are opposite angles. Okay. So adjacent angles are supplementary. You can write anything. Any one you can write. Okay, you can write any one. So you can write, say, angle D plus angle C is equal to 180 because the adjacent angles are supplementary. All right, so D is 90 plus angle C is equal to 180. So angle C is equal to 90 degrees. So we found C is 90. We found C is 90. Now again, using the property of a parallelogram, opposite angles are equal. So if C is 90, A is also 90. You can use adjacent angles itself everywhere also. So see, like you can, any property, whichever makes your job easy or whichever takes less time. See, you can just use the property of adjacent angle itself. Angle D plus C is equal to 180. Supposing you don't remember the opposite angle property, it's okay. Angle D plus angle C is equal to 180. Adjacent angles are supplementary in a parallelogram. So 90 plus angle C is equal to 180. C is equal to 90. Then again, C plus B is equal to 180. Adjacent angles are supplementary. Okay, so 90 plus angle B is equal to 180. So angle B is 180. Again, B plus A is equal to 180. Angle B plus angle A is equal to 180. B we found is 90. So 90 plus A is 180. Like this also, just by using the adjacent angle property, adjacent angles are supplementary, you can do it. But what did we do? Opposite angles are equal, so this is 90. Then adjacent angles are supplementary, so this is 90. Then again, opposite angles are equal, so this is 90. All right. So we proved that each angle of a rectangle is a right angle. All right. Okay. Let me just explain everything and then we'll start writing because I have the option. Supposing we don't have time to write also, I can share the images with you and you can write it at home. Most of you are on your vacation, right? Except for your school and your school. Oh, yeah. Okay, but anyways, you're responsible children, so you will do it sometime. So we'll discuss all the proofs and then if we have time, we'll write in today's class. Else I'll share the images and you can complete it later. Show that the diagonals of a rhombus are perpendicular to each other. Diagonals of a rhombus. So the given quadrilateral is a rhombus. See, when you're given a quadrilateral, when you're given a special quadrilateral, you can use all the properties of that quadrilateral except what you have to prove. See, it's given it's a rhombus. You can use all the properties you know about a rhombus except what you have to prove. Show that the diagonals of a rhombus are perpendicular to each other. Yeah, we know the diagonals. We know that there's a property of a rhombus. The diagonals are perpendicular to each other. That's what you have to prove. So you have to prove that. So leave that. Other than that, the remaining properties of a rhombus you can use to prove. All right. Remaining properties meaning the definition, like what is a rhombus? A parallelogram in which all the sides are equal. All right. Other than what you have to prove, you can use the other properties of a rhombus here. All right. So rhombus, you know, all sides are equal in a rhombus. All the sides are equal. We need to prove that AC is perpendicular to BD. That is, we need to prove that angle AOD is 90 degrees. AOD is 90 or AOB is 90 or BOC is 90 or COD 90, any one angle. That means AC is perpendicular to BD, right? Yeah. So it's a very simple one. You just have to prove that, say this angle is 90 degrees. If you prove this 90, that means AC is perpendicular to BD. And to show that this is 90 degrees, we can take up these two triangles. See, you have many combinations, you know, you can take up this triangle and this triangle, or this one and this one, or any two adjacent triangles. Let me put it that way. You can take any two adjacent triangles, or you can take up this triangle and this triangle, or you can take this and this. All right. Take any two pairs of adjacent triangles and show that they are congruent. Once you show they are congruent, corresponding angles are equal. Just a second, children. One second, just a second. Okay, so we just have to, yeah, thank you, online students. Yeah, thank you here also. So children, take up any two adjacent triangles. You're angry with me? No, no. All right? Yeah. Take up any two adjacent triangles. Cricket விளையாடிட்டே இருந்த அம்மா கிளாஸ் இருக்குன்னு அனுப்பிச்சு விட்டாளா? Yeah, take up any two adjacent triangles and show that they are congruent. So any two, I told you, any two. So we take these two. All right, so in these two triangles, AB of this triangle is equal to AD of this triangle because in a rhombus all sides are equal. Then OB of this triangle is equal to OD of this triangle. What did we understand? We can use all the properties except what we have to prove. We know that a rhombus is a parallelogram. We know that a rhombus is a parallelogram, and in a parallelogram, diagonals bisect each other. O is the midpoint of BD, O is also the midpoint of AC. In a parallelogram, diagonals bisect each other. That means both the diagonals have the same midpoint. O is the midpoint of both the diagonals. So that means BO is equal to OD. We can use that. Okay, and then AO is the common side. SSS rule, the triangles are congruent. CPCT, angle 1 is equal to angle 2. It's not 90 now, we have to prove it. CPCT, angle 1 is equal to angle 2, but angle 1 plus 2 is equal to 180. They form a linear pair because it's a straight line. BOD is a straight line and BOD is a straight angle. This one is a straight angle. Because BOD is a straight line. Diagonal is not a broken line like this, no. Diagonal is a straight line. So at any point on the diagonal, the angle is 180 degrees. Any point you take on the diagonal, the angle is 180. Any point you take, the angle is 180. So 1 plus 2 is 180, right? But 1 and 2 are equal angles. We just proved that they're equal. Angle 1 is equal to angle 2. So angle 1 plus angle 1 is equal to 180. Twice of angle 1 is 180. Angle 1 is equal to 180 by 2, 90 degrees. So angle 1 is 90. Angle 1 or angle 2? Both are equal, no? Angle 1 is 90. Wasn't that easy? Understood, all of you? Online students? Any questions?
No, ma'am.
Okay. See, same proof, whichever triangle you take. Supposing you take this triangle and this triangle. These two triangles. Same thing. AD of this triangle is equal to CD of this triangle. In a rhombus, all sides are equal. OD is the common side to both the triangles. Then for diagonal AC, O is the midpoint. So OA of this triangle is equal to OC of this triangle. So same SSS rule, the triangle is congruent. CPCT you can, okay, CPCT angle 1 is equal to angle 2, but angle 1 plus 2 is equal to 180. So angle 1 plus 1 is equal to 180 because 1 and 2 are equal. So you can write 2 plus 2 or 1 plus 1. So like that you will get angle 1 is 90 or 2 is 90. So if this angle is 90 degrees, that means the diagonals are perpendicular to each other. You can just, I'll just give you 3 minutes, just go through the proof. Don't write in a hurry now, just read the proof. All right. Okay. Next one. So in this figure, ABC is isosceles. In this figure, ABC is isosceles. Next class, we'll do from the chapter circles. I'll do the numerical ones first. Circles has been done in your school, right? Completed? No? No. Yeah, so we'll do the new. So those of you who have learned in school, you know, you have numerical, situations also from this chapter circles, right? Apart from proofs, theorems and proofs in the exercises, you also have numerical situations. So next class, we'll take the introduction to circles and we'll do the numerical ones from circles and then come to the theory part, the theorem part. And from the next week onwards, we'll start the revision also for the exam in the sense, do you get case study based questions in your paper? Some schools follow that pattern, some schools don't follow. They follow. Yeah, then we'll do that also. Next Tuesday. This Friday, I'll do circles. Then we'll side by side, we'll revise. We'll, discuss case study based questions from various chapters. That is, we'll do revision and circles parallelly. Yeah. Exam timetable announced for the final exam? No, not yet. Yes, when? Jan end. Jan 18th. Two. Second week. Here, online students, annual examination timetable has been announced?
No, ma'am.
No. Bhavishya, no.
No, ma'am.
Swati, yes. Okay, the others, no. All right. All right. So in this figure, ABC is an isosceles triangle. AD, this one, AD bisects this angle. This side is equal to this side. ABC is isosceles, which means this angle is equal to this angle. Correct? Isosceles triangle property. If given these two sides are equal, so the angle opposite to this side is this angle. The angle opposite to this side is this angle. So these two angles are equal. Angle 1 is equal to angle 2. It is given that AD bisects angle PAC. AD bisects angle PAC. Which is PAC? This one. This angle. This one bisects PAC. That means angle 3 is equal to angle 4. Correct? Bisects means dividing the angle into two equal portions. Okay. So angle 1 is equal to angle 2 because ABC is isosceles. So angles opposite are equal, sides are equal. Angle 3 is equal to angle 4 because it's given that AD bisects angle PAC. Now we need to prove that DAC using our numbers, which is DAC by our numbers, which is DAC 4 and BCA 1. BCA is 1. We need to prove that angle 4 is equal to angle 1. We need to prove that 4 is equal to 1. We need to prove that 4 is equal to 1. Now don't say 4 is equal to 1, alternate angles are equal. AD is not given parallel to BC. And we should not assume that, yeah, A, B, C, D, they look like this. A, B, C, D, they look like this. It looks like a parallelogram. No, it's not given it's a parallelogram. Because it looks like a parallelogram, you cannot assume that these two sides are parallel. Okay. And also to say that angle 1 is equal to angle 4 using alternate interior angles, these two lines have to be parallel. It should be parallel line, transversal parallel line. Then only angle 4 is equal to angle 1. Alternate angles are equal. Correct? Okay. Now, how do we do this? Very easy. See here. Now, angle, no, let me just. This is only PAC, right? PAC, this one. PAC. And this is angle 2 and this is angle 1. So I've just taken a part of the figure, correct? Angle PAC is the exterior angle to the triangle ABC, correct? Look at the triangle ABC. The side BA has been produced to P. I've taken up only the isosceles triangle ABC. I've taken only the isosceles triangle ABC in which we have AB equals AC and from which we get angle 1 is equal to angle 2. So we have taken that isosceles triangle and the extension of the side BA. BA is produced to a point P, right? Yeah. Now this is the exterior angle. Exterior angle is equal to the sum of the two interior opposite angles. Correct? Repeat the property, Sahana. Next, Niveda. Louder. Repeat. Interior opposite angles, right? Okay. So, yeah, that's a property. Repeat now, Sahana. Or tell me in this triangle. No, not in this. Okay. What is angle 1 equal to by the property? Angle 3 and? Very good. Okay. Okay, so now angle PAC. Angle PAC is equal to angle 1 plus angle 2 by the exterior angle property. All right. Now, by our marking, what is PAC? Angle 3 plus angle 4. Correct? Is equal to angle 1 plus angle 2. We've used the exterior angle property. Angle PAC is the exterior angle. It is equal to angle 1 plus angle 2 in the triangle. Now PAC is nothing but angle 3 plus angle 4 is equal to angle 1 plus angle 2. But we know that 3 is equal to 4, right? See, we have to prove that angle 4 is equal to 1. So you want this angle 4 is equal to this angle 1. You don't want 3 and 2. You want this result 4 is equal to 1. Because you can see here, angle 4 is equal to angle 1 is what we have to prove. You don't want 3 and 2. So what do? Angle 3 is nothing but angle 4, no? Angle 3 is nothing but angle 4. And what about angle 2? It's equal to angle 1. Angle 2 is equal to angle 1. Isosceles triangle. Angle 2 is equal to angle 1. And 3 is equal to 4 because that angle is bisected. So 3 is equal to 4. So you write what you want. You wanted first use the exterior angle property. Then you should understand what you want and what you don't want. You want this result angle 4 is equal to angle 1, which means you want angle 4 and angle 1. You don't want 3. So how will you take away 3? You should take away 3 and introduce 4 or 1. Should take away 3 and introduce either 4 or 1 because you want only 4 and 1. But 3 is equal to 4. Similarly here, 2 is equal to 1. So you get twice of angle 4 is equal to twice of angle 1. Please don't write angle 4 plus 4 is angle 8. No, right? Angle 4 plus angle 4 is twice of angle 4. So 2 on either side gets cancelled. Angle 4 is equal to angle 1. So we proved that angle 4 is equal to angle 1. So always number the angles. That will be more easy to understand the situation than writing PAD, DAC. No, that's difficult. Because if it's now English, when you can just read and understand what it means. But Nadunalla, when it is angle PAD, you have to read PAD, see the figure. PAD, okay. Then you have to come back. Then if you read something like BDP, you have to again come here BD. So that's what that way what happens, that the continuity is not there. Then after you do that, you forget what you read first. So you again come back. But when you number, it's easy to understand. Because one glance, you can see, like if you number, now what you have to prove, angle 4 is equal to angle 1. If you look there, 4, 1, understood which one you have to prove. But if you have to read angle DAC is equal to BCA, DAC, BCA, don't you have to do that? Yes or no? Nobody's telling yes. So number it. Okay, so when you number it, it's easy to understand immediately what you have to prove. Next, ABCD is a parallelogram. We have to prove that ABCD is a parallelogram. See, we are already given one information. CD is parallel to AB is already given. CD is parallel to AB is already given. So if you prove that this is parallel to this, done. In a quadrilateral, if both the pairs of opposite sides are parallel, it's a parallelogram. Now, how do you prove that this is parallel to this? Angle 4 is equal to angle 1, but they form a pair of alternate interior angles made by the transversal AC with the lines AD and BC, and the alternate angles are equal. So the lines are parallel to each other. I'll repeat this last part alone. Numbering, don't mind. I might have changed now. So we got the result. Let me not confuse. What did I put here? 4, I think. 4 and 1 I put here. Yeah, I'll let you know. So, no, yeah. So how do we prove that ABCD is a parallelogram? AB parallel to CD is given in the question. So we have to prove that AD is parallel to BC. If we do this, then both the pairs of opposite sides are parallel. So the quadrilateral is a parallelogram. Now this one, see, some line, transversal, some line. Here we have proved that angle 4 is equal to angle 1. Angle 4 is equal to angle 1. Here we have proved, right? Now this is 4. This is 1. These two angles are equal. We just proved. But what kind of angles are they? They're alternate angles. They're alternate angles. And they're made by this transversal. made by this transversal, that is transversal AC, with which two lines? With this line and this line, with the lines AD and BC. So those two lines are parallel to each other. Which two lines? This line AD is parallel to BC. AD is parallel to BC. So if AD is parallel to BC, now both the pairs of opposite sides are parallel, hence it's a parallelogram. Go through. Please go through the answer, children. All right. Next one. You want it for some more time? Next one. Two parallel lines, L and M. The diagram is not given, so we have to draw by reading the statement. Two parallel lines, L and M. So you can draw them like this, or you can draw it like this. Anyways, but we'll always choose the most comfortable way to draw like this, right? Why do you want to draw like this? You can draw like that, you can draw like this, you can draw like this. Anyways, it's fine. But when we say parallel, we normally like parallel lines like this. So two parallel lines, L and M. Two parallel lines, L and M, are intersected by a transversal P. So the transversal you can do like this. You can put it straight. You can don't put a straight one. That will become like 90 degrees. So don't do that. You can anything like this is a transversal. Any line that cuts these two parallel lines is a transversal. So it can be inclined anyways. Anyways, so say like this. Any inclination. Okay, so this is the transversal P. Transversal is a line that cuts these two parallel lines are intersected by a transversal P. So the transversal P intersects the two parallel lines at which points? This point and this point. The transversal P intersects the line M at this point and the line M at this point. Correct? Show that the quadrilateral formed by the bisectors of the interior angles is a rectangle. Okay. Now, tell me in this figure, how many angles are formed around the transversal? Wake up, all of you. How many angles are formed around the transversal? Online students, how many angles are formed around the transversal? 8 angles. Very good. 8 angles are formed around the transversal. Of the 8 angles, 4 angles are called dash and the remaining 4 angles are called dash. Very good. Very good. Yeah. So 4 angles are called interior angles and the other 4 angles are called exterior angles. Those interior angles only they're talking about. Show that the quadrilateral formed by the bisectors of the interior angles. They're talking about those 4 interior angles. So 1, 2, 3, 4. These are the 4 interior angles. Bisectors of the interior angles. Interior angles, bisectors of the interior angle. Now this angle, the bisector will pass through this point, the middle part of that angle, right? Like this. Now this is the angle, right? So I'm kind of marking the midpoint on the arc here. So the bisector will be like this. Bisecting the angle, then this one. And I'm just marking the midpoint on the arc like this. This is the bisector. And here, this is the midpoint. So this is the bisector. So we have drawn the bisectors of the 4 interior angles. The remaining 4 are exterior angles. These are the 4 interior angles, and we have shown their bisectors. You need to prove that the bisectors enclose a rectangle. Can you see the figure here? Anybody disturbing you? Okay, you need to show that the bisectors enclose a rectangle. So that is, this one is a rectangle. That's the quadrilateral, right? Enclosed by the bisectors. The 4 bisectors, they cover something. They cover a quadrilateral. You should prove that that quadrilateral is a rectangle. Can we see the 4 bisectors going, one going like this, another one like this, another one like this, another one like this? They're enclosing a quadrilateral, right? You need to prove that it's a rectangle. This quadrilateral is a rectangle. Understand? Okay. Now, I'm not going to mark anything. I'll just tell you orally and I'll show you the slide. Okay. But I'll do it slowly. Now, this angle, see, these L and M are parallel lines. L and M are parallel lines. They're parallel lines. Okay. This angle and this angle, what kind of angles are they? Alternate interior angles. Okay. So is this angle equal to this angle? Yes. Okay. Then will half of this angle be equal to half of this angle? Yes. So what is this half of this angle? This one. What is half of this angle? This one. Because the angles are bisected. How do we know their halves? Because they're bisected. Otherwise, we will not know their halves. The 4 interior angles are bisected. So we know their halves. This is one half, this is the other half. Any half you can take. But you should take the half which is more convenient for you. All right. Yeah. Yeah. All right. So I'm saying this angle is equal to this angle, right? Right? Why? Alternate angles are equal. Half of this angle is this one. Half of this angle is this one. These 2 angles are equal because halves of equals are equal. Now let's just understand where these angles are formed. There is a line. There's a transversal. There's a line. And here you find these 2 angles. Yes or no? I'll show those lines in some of the color, yellow. Here. This line, this transversal, this line. Can you see those angles? See, one X is here between this one and this one. The other X is here between this and this. Yes or no? Okay. Now these two angles are equal, no? But they're alternate angles. They're equal. How do you know they're equal? We just got that result, no, that they're equal. We just got that result that they're equal. No, but they're alternate angles. So that means these two lines should be parallel. This line is parallel to this one. So that means this line is parallel to this line. Repeat the same thing with the other pair of interior angles. Repeat the same with the other pair of interior angles. This angle is equal to this angle. Why? They are alternate angles because L is parallel to M. Because L is parallel to M, cut by a transversal, this angle is equal to this angle. Alternate angles are equal. So half of this angle, which is this one, is equal to half of this angle, which is this one. Okay, when two angles are equal, their halves are also equal. All right? Yeah. Now, yeah, I hope this color is visible. Now you can see a line, transversal, a line. You can see 1x here, 1x here. This one, I'll just show using a blue line. So see here, this is the line. This is the transversal. This x is between this line and this line. Can you see the blue lines? The blue lines forming the Z. So this is the Z formed by the blue line, this one. So one angle is equal to one angle, alternate angles are equal. So half of these angles are also equal. So one half of this one, the other half is this one. But if you look at these two angles, they're alternate angles made by this transversal with these two lines. So that means now these two lines are parallel to one another. Parallel line, some line, transversal, some line. Some line, transversal, some line. These two angles are equal, but they're alternate angles. So these two lines are parallel. But these two angles, you know, we got that they're equal, not using alternate angle, not using these two lines, some other two lines. 1 second. If you have a doubt like that. Now, why is this angle equal to this angle? Because L is parallel to M. L is parallel to M. And this is the P is a transversal. See here. L, P transversal M. That's how we get these two angles are alternate angles. This one and this one is because L is parallel. This is the transversal to M. L is parallel to M like this. So this angle is equal to this angle because L is parallel to M, P is a transversal. This angle is equal to this angle because L is parallel to M, P is a transversal. So their alternate angles are equal. These bisectors, you know, these are different lines, these bisectors. We are proving that these lines are parallel now. We are proving that the lines made by the bisectors, they are parallel. For that, let me number it now. We proved that angle 1 is equal to angle 2. So this is parallel to this. Then we proved that 3 is equal to 4. So this one is parallel to this one because alternate angles are equal. So these two lines are parallel. So like this, we have proved that both the pairs of opposite sides of the quadrilateral are parallel. So it's a parallelogram. In this quadrilateral, both the pairs of opposite sides are parallel. So it is a parallelogram. Now, how do you prove that it's a rectangle? You must use the definition. In a parallelogram, when one angle is a right angle, it's a rectangle. So we proved it's a parallelogram. Now we'll have to prove that one angle is a right angle. Okay, for that. For that, what you do? Take up this angle. This one is a straight angle, no? This one is a straight angle, right? 180. Use the marking here. This one is a straight angle, right? Correct? So that will be 180. That's 180. So see here. PAC plus SAC is 180. See here, PAC. PAC plus SAC is 180. Yeah, because it's a straight line. So half of PAC will be equal to half of, sorry, this angle plus this angle is equal to 180. Now divide both the sides by 2. So half of PAC plus half of SAC is equal to 180 by 2, right? 180 by 2 is 90. Now what is half of PAC? Half of PAC is, since this angle is bisected, this is the angle PAC. It's bisected. So this angle is equal to this angle. So we'll write half of PAC as BAC. BAC. Similarly, half of this angle, see here, SAC, half of SAC. SAC is this angle. Its halves are this one and this one. We'll write this one, DAC. DAC is equal to 90. Now, what is BAC plus DAC? What is BAC plus DAC? The sum of these two angles. It is BAD. It's BAD. So like this, you prove that BAD is 90. So if you prove that BAD is 90, that means in this quadrilateral, in this parallelogram, we prove that one angle is a right angle. So it's a rectangle. I want you all to go through this proof. We'll see it again because online students somewhat understood. Anirudhan, Laksha, Sadhna, Sabarna, Swati.
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay, please go through the proof. We'll do it together again. Just read through the proof. We'll discuss again. So it's important to label the points, you know. See what all to label. Of course, these intersecting points, you know, this one and this one. To name angles, you need letters, right? So supposing you call this A and this one B. On this line L, you should take 2 points, say C and D. On this line M, 2 points, E and F. This should be sufficient. On every line you have, no, you should have at least 2 points marked. Only then you can name the angles. Every line you have, there should be at least 2 points. So here you can see on the line L we have, okay, A and B is actually from P we named. A and B from P, A and B on the line P we marked. Okay, now on L we marked C and D. And on M we marked E and F. So now you can name the angles. Angle CAB. Okay, I think to name this angle, we need to take this point also like that. So according to your requirement, now after marking this, I just realized that now how do I name this angle? How do I name this angle? So that means I need a point here. EFG. Then only I can say GAD. Or I can say GAC. In the same way, how do I name this angle? EB. You can't say EBP. You cannot say EBP. No, that's wrong. This cannot be used to name angles. This letter cannot be used to name angles. Okay, so you need to take a point here. H. So EBH. Okay. Now you can see with these points, you can name this angle, this angle, this angle, this angle. All the 8 angles can be marked. Sorry, all the 8 angles can be named using these markings. So how do we start? We start with this angle equal to this angle, correct? Alternate angles are equal. Half of this angle is equal to half of this angle. That's what I've written here. This angle equal to this angle is what you see here. Half of this angle is equal to half of this angle. And half of this angle is this one, half of this one is this one. That's what is here. BAC. BAC is equal to ACD. Okay, and after that I didn't, in the diagram earlier, I didn't show the bisectors to mark. So the bisectors, when they meet, you should take a point again there. These two bisectors, when they meet, a point there. Now we were talking about labeling the points, right? Yeah. So these two bisectors, they meet. Give a name for that point, and then these two bisectors where they meet, name that point also. So now this angle is equal to this angle, but they form a pair of alternate interior angles. So this line is parallel to this line. Repeat this procedure on the other side. This angle is equal to this angle. So their halves are equal. So this angle is half is this one and this one. These are the halves. Here the halves are this and this. So you choose this one and this one. These two angles are equal, but they're alternate angles. So this is parallel to this. So we already had this parallel to this. Now we prove that this one is parallel to this one. So it's a parallelogram. Now in this parallelogram, you need to prove that one angle is a right angle. Only then it's a rectangle. Definition. So we proved that this one is 90. We proved this is 90. How? We took the whole angle, this whole angle. This full thing is 180. Angle PAC plus angle SAC is equal to 180. Linear pair. So now divide by 2 on both the sides. This one by 2, this one by 2, this one by 2. It's nothing but half. Dividing every element, every term by 2. It's also half, right? Half of PAC plus half of SAC is equal to half of 180. You're praying now? Yeah, tell me. So half of PAC. Half of this angle is, these two are the equal portions. And for this angle, half of this angle, these two are the equal portions. Okay, so for half of PAC, we'll write this one. For half of SAC, we'll write this one. But these two put together is BAD. These two put together is BAD. So we get BAD is 90. So we proved that in the parallelogram, one angle is 90 degrees, so it's a rectangle. You can do the same thing here also. You can choose this one. Repeat same steps. You can work for these two angles. You can say angle, this angle plus this angle. This angle plus this angle is 180. Half of this angle plus half of this angle is equal to 180 by 2. 90. So half of this angle is this one. Half of this angle is this one. So these two, this angle plus this angle is equal to 90. but these two put together is BCD. You can do it in a different way also, I think, but we'll stop with this. I'll just make it fast if you can understand. If I'm clear, we'll go ahead with that. You can also use this angle. This angle plus this angle is 180. Why? Co-interior angles are supplementary. Half of this angle, that is this one, plus half of this angle, that is this one, is equal to 180 by 290. Because sum of two angles is 180. We are dividing by 2 everywhere. So 180 by 290. So we get this angle plus this angle is equal to 90. So in this triangle, what will happen? In this triangle, if the sum of these two angles is 90, this angle will be 90, no? Now ignore the 90 which was already marked. That is not given. Don't get confused. I never said that also. That's not 90. I did not say that. Yeah, so don't say it was already marked there. That we don't have from anywhere. I'll remove that marking, but so you can say this angle plus this angle is 180. Co-interior angles are supplementary. Half of this angle plus half of this angle. So their halves will be this and this is equal to 90. So the sum of these two angles is 90 degrees. So in this triangle, if the sum of these two angles is 90, this angle has to be 90. Angles and property is 90. So in this quadrilateral, which is already a parallelogram, which we've already proved is a parallelogram, in this quadrilateral, which we've already proved is a parallelogram, correct? No, call is disturbing this one. Yeah, which is already a parallelogram. Okay, we proved that one angle is a right angle. So it's a rectangle. Just hello. Hello. Yeah, you can repeat. You can try to do the same thing here. The sum of these two angles is 180. So that means this angle plus this angle is 90. So in this triangle, the sum of these two angles is 90. So this angle is 90. So in the parallelogram, one angle is a right angle. So it's a rectangle. Show that the bisectors of angles of a parallelogram form a rectangle. Now these results you should remember. 1 mark they will ask you. Same thing. The quadrilateral formed is a rectangle. This one can also be a 1 mark question. MCQs. Rectangle. The answer is rectangle. I hope you understand what I'm saying. Here also. They'll ask you MCQs. So here we have a parallelogram. We have a parallelogram. Okay. The bisectors of the interior angles. Bisectors of the interior angles. So which are the interior angles? Okay, here it's given bisectors of the angles. When we say interior angles here, the 4 interior angles. 1, 2. Bhavishya, kindly disable your mic, or Sadhana. Who's that? Sadhana and Sabarna. Okay, so these are the 4 angles, or the interior angles of the parallelogram. Bisectors. So this angle is bisected like this. This angle is bisected. So like this. They'll go on. The bisect. We are just cutting it. Okay, they'll go on like this and like this. But you don't want to go outside the figure, no? It'll look clumsy. So okay. This is angle D, bisector. This is how you draw a rough diagram. You should mark. You would have used an arc to mark that angle, right? Just roughly mark the midpoint and connect the vertex through that point. You will get almost the bisector, freehand bisector. Now you need to prove that this one is a rectangle. The bisectors, they form a rectangle. You should prove that this one forms a rectangle. Okay, 1 second. I'll just show you again. See here. When you draw the bisector of this angle, it will go like this. It will go for this angle. Parallelogram, this angle, bisector, this angle, bisector, this angle. So these lines, these are big, these are lines, no? So, oh my. You understand what I'm doing? Now here you see, no, this one. The bisectors, you must prove that they enclose a rectangle. Bisectors, you must prove they enclose a rectangle. So in the figure, no, we are not showing these extended portions. We're just trimming those lines. Okay. You can draw like this if you wanted the exam, You can draw like this, like an envelope. Just put one triangle like this. Okay. We need to prove this one is a rectangle. Now let's start. Similar to what we just did. Parallelogram, this is. This angle plus this angle is what? 180. Because adjacent angles are supplementary. It's a parallelogram. So half of this angle is this one. Half of this angle is this one. Will be equal to 90. So in this triangle, the sum of these two angles is 90. So the third angle, this one will be 90, right? In a triangle, 2 angles. In this triangle, this angle plus this angle is 90. Why? Because this plus this is 180. So when you do that process, half, you get this angle plus this angle is 90. So in this triangle, The sum of these two angles is 90. So third angle. See, in the triangle, don't see this one. Don't see this. This is not there in this triangle. You understand? Now repeat that 3 times using different angles. Repeat that using 3 times using different angles. Excuse me for the bad figure. Okay, so now we proved this is 90. This one we proved is 90. We took these two angles, right? Now take this angle and this angle. The sum of these two angles is equal to 180 co-interior angle. Sorry, adjacent angles. They are also co-interior angles. Okay, adjacent angles are supplementary. So half of this angle, that is this angle, is equal to half of this angle, or not equal to, sorry. This angle plus this angle is equal to 180. Half of this angle plus half of this angle is equal to 180 by 290. Half of this angle is this one. Half of this angle is this one. Is equal to 90. The sum of these two angles is 90. So in this triangle, the sum of these two angles is 90. So third angle, this one has to be 90, no? So vertically opposite angles, this one will be 90. Vertically opposite angles. So we got this one plus this one is 90. So by angle sum property, this is 90. Then by vertically opposite angle, this one will be 90. Now repeat here. This angle plus this angle is equal to 180. Half of this one plus half of this one is 180 by 290. So this angle plus this angle is 90. So which is the triangle in which we have these two angles? This triangle. This triangle. In this triangle, we have this angle and this angle. So this angle is 90 degrees. Straight away we'll get this 90. No need to use vertically opposite angle. Straight away we get the angle in that figure. Correct? This is 90. Now, in a quadrilateral, when 3 angles are 90, the fourth angle has to be 90, no? So in this figure, we have proved that all the 4 angles are right angles. Now use the definition. Now what are the criteria for a quadrilateral to be a parallelogram? In a quadrilateral, when both the pairs of opposite angles are equal. In a quadrilateral, when both the pairs of opposite angles are equal, it's a parallelogram. Both pairs of opposite angles are equal, it's a parallelogram. So here 90, 90, 90, 90, opposite angles are equal. So it's a parallelogram. And when is it a rectangle? If one angle is a right angle. All the 4 are right angles, but okay, by the definition, one angle is a right angle. So it's a rectangle. We have proved all the 4 angles are 90 degrees. Okay. Now how do we continue? First, see, we have to prove that it forms a rectangle. Definition, parallelogram, right angle. Parallelogram because both the pairs of opposite angles are equal. So parallelogram. Rectangle because one angle is a right angle. All are right angles, but one angle is a right angle. So rectangle. So angle 1, you will first get angle 1 plus angle 2 is 90. So angle 3 is 90. Then you will get angle 4 plus angle 5 is 90. So angle 6 is 90. So angle 7 is 90 because vertically opposite angles are equal. Then you will get angle 8 plus angle 9 is 90. So angle 10 is 90. That you'll get inside the triangle itself. Only here you should use vertically opposite angles. Or if you use this side, if you use also, you should use vertically opposite angles. When you take this angle plus this angle is 180. That's how you start. This angle plus this angle is 180. Then when you take the half, you'll get angle 1 plus angle 2 is equal to 180 by 290. So 1 and 2 are in which triangle? PAB. In PAB, we have 1 and 2. So this angle is 90. Then again, when you use these two pairs, you will get angle 3 plus angle 4 is 90. And these two angles are in this triangle, this triangle. So you will get 90 here. So vertically opposite angle, this one is also 90. Then you will use this angle plus this angle is equal to 180, then half. So you'll get 5 plus 6 is equal to 90. Where do we have these angles 5 and 6? In this triangle. See, in this triangle. This triangle we have 5 and 6. So 5 plus 6 is equal to 90. That means this angle is 90. Because if two angles 90, third angle will be 180 minus 90, 90. So in this quadrilateral PQRS, three angles right. See, you can do the same thing here also. This angle plus this angle is 180. So you will get what? 7 plus 8 is equal to 90. So this one is 90. This one is 90. Vertically opposite angle, this one is 90. You can repeat that. Or after finding three right angles, use the angle sum property of a quadrilateral. Three angles 90. So fourth has to be 90 degrees. Now in this quadrilateral, PQRS, we have proved that every angle is a right angle, right? But you can't say every angle is a right angle, so it's a rectangle. You cannot say that. You should use the definition. So you must say that PQRS is a parallelogram because both the pairs of opposite angles are equal. Then you must say that in the parallelogram, one angle is a right angle. All are right angles, but for the definition's sake, one angle is a right angle. So it's a rectangle. There's another proof. We'll not do that now. We'll do it in the next class. Meaning for the same thing, there's another. You can do it differently. Understood this one? Yeah, go through this one. Let me go 1 and 2. You will see, understand, and explain. Then I'll continue from 3, 4, 5. That's all. With this, we'll finish quadrilaterals. You're using the rationalized syllabus, right, in your school? Teacher, the proofs you've learned in school are based on the rationalized syllabus, right? Yeah, because even I removed. There are many more sums in this exercise, but I've just put only in this presentation. You can see only the ones which is now in the rationalized syllabus. The others I just removed them. 1 and 2 you will, or meaning you will tell me. Then I'll continue from 3. Go through. Okay. So if the diagonals of a parallelogram are equal, then show that it's a rectangle. This is a property. In a parallelogram, we know that opposite. Yeah. So in a parallelogram, we know that opposite sides are equal. But diagonals are in a parallelogram, opposite sides are equal and diagonals are parallel. Bisect each other, but something else.
Diagonals are not equal.
Yeah, diagonals are unequal. That's what is related to the context here. That's what is related to the context here. My question was not vague. It was to the point because that is what is related here. In a see, if the diagonals of a parallelogram are equal, so we're trying to understand if the diagonals of a parallelogram are equal, then show that it's a rectangle. So parallelogram, rectangle. So we are trying to understand that in a parallelogram, opposite sides are equal. Rectangle also, opposite sides are equal. In the parallelogram, when the diagonals are equal, that means the diagonals are unequal in the not that means we know that the diagonals of a parallelogram are unequal. If they are equal, it's a rectangle. So not that, then where will the parallelogram go? It is a parallelogram. A rectangle is a parallelogram. A more special name. It's a rectangle. Like what? So like living things. So what are the characteristics of living things? Living things? Living things eat. That's living, okay. Living things move, living things grow, living things respond to stimuli. So like that, we've learned so many things about living things, but then we say non-living things. They don't grow, they don't respond to stimuli, they don't eat, they don't sleep. Okay, whatever. Now, in living things, under living things, we say plants and animals, right? So where we have a nervous system, creatures that have a nervous system, not creatures, living things that have a nervous system. And animals does not have a nervous system. Plants. Correct? That's what everybody is nodding. What's the difference between plants and animals? Plants don't make their own food, huh? Okay, plants make their own food. Animals depend on plants for their own, depend on plants for food. Okay, so like that. So you keep coming down, right? So first you started with living and non-living things. In living things, you say plants and animals. Then when you call an animal a man, so you have features like that. No, you keep coming. You can keep giving special names, special names, special names. You can keep giving special names, right? Okay, if you take the animal kingdom, so tell me the class of, no, what is phylum, right? The different phylum in the animal kingdom? No, not learned? Not in syllabus. Okay, let's not move ahead. Fine. No. If it's not a common topic, we'll not discuss that. So in a parallelogram and rectangle, opposite sides equal, opposite sides equal. Opposite sides equal, opposite sides equal. Diagonals not equal. Diagonals equal. So in the parallelogram, when the diagonals are equal, it's a rectangle. As long as the diagonals are not equal, it's only a parallelogram. It's not a rectangle. But when the unequal diagonals, they are equal, It is a parallelogram, but a still special name is a rectangle. And that's what it is saying. Okay, so we're given a parallelogram. ABCD here. Okay, where the diagonals are equal, you'll have to show it's a rectangle. So how do you show it's a rectangle? Your definition, see, the thing is always how to start. How do I know that I have to do this? Definition will tell you. See, when you read the statement, okay, but how do I start is the next question. Not at all difficult to understand how to start, because what should you prove? Rectangle. What's the definition of a rectangle? Parallelogram, one angle 90 degrees. But you're already given a parallelogram, right? So that job also you don't have. You just have to prove that one angle is a right angle. That's all. How to go about the proof? The answer lies in the definition of the, to be result. What is the result here? You'll have to show it's a rectangle, correct? So if you have to show it's a rectangle, use the definition. You should have a parallelogram in which one angle is a right angle. But the given figure is already a parallelogram. So yeah, and before that, I should tell you one more thing. Whenever the diagram you draw should suit the final result. The diagram you draw should suit the final result. Now here it's given that prove that in the parallelogram when the diagonals are equal, prove it's a rectangle. So you should not draw the diagram like this. You must draw the diagram like a rectangle. Because you cannot do this and finally say that therefore ABCD is a rectangle. ABCD does not look like a rectangle. The figure should always match the result. The result is rectangle, right? So you must draw. Now this one is a parallelogram. This rectangle, this figure or the shape that looks like a rectangle is a parallelogram. This shape or this figure that looks like a rectangle is a parallelogram. You can draw this one and say it's a parallelogram. Yeah, it is a parallelogram. But you cannot draw this and say this is my rectangle. Yeah. So the first thing is the figure you draw should suit the final result. That's why given parallelogram ABCD, but if you look at ABCD, it's a rectangle, but it looks like a rectangle, but it's a parallelogram also, right? Yeah. So parallelogram ABCD with AC equal to BD. That's what is given. Do we understand? We are given a parallelogram. So here ABCD with diagonals equal with AC equal to BD. We need to show it's a rectangle. So for that, you just have to prove one angle is a right angle. Because it's already a parallelogram. So only one angle, right angle, then it becomes a rectangle. So take up these two triangles. Take up these two triangles, this triangle and this triangle. That is, you should take up you must take up one triangle that has AC, another triangle that has BD. You must always use triangles. Some information is given, right? You should be able to use that information. See, supposing you take this triangle and this triangle, how will you use that information? AC equal to BD. Consider two triangles where you can use the information provided. AC and BD. AC is one diagonal, BD is the other diagonal. So we take this triangle where we have diagonal AC, this triangle where we have diagonal BD. Okay. So in these two triangles, AD is equal to BC. Why is AD equal to BC? In a parallelogram, opposite sides are equal. This is the common side. And then this diagonal is equal to this diagonal given. These are not two different triangles, children, please. These are not two different triangles. I've cut it from here and here. All right. Okay. So this side is equal to this side because opposite sides of a parallelogram are equal. Common side, diagonal AC is equal to diagonal BD given. SSS rule, the triangles are congruent. CPCT, you have angle 1 is equal to angle 2. You should know how to name the triangles in the correct order. You should name the triangles in the correct order. So ADC, BCD, ADC, BCD. So these two triangles are congruent by SSS rule. CPCT, angle 1 is equal to angle 2. That is this angle. This angle 1 is equal to this angle 2. This angle 1 is equal to this angle 2, CPCT. But they are co-interior angles, right? Angle 1 is equal to angle 2, CPCT. But 1 and 2 are co-interior angles or adjacent angles. So they're supplementary. Angle 1 plus angle 2 is 180. That means angle 1 plus angle 1 is equal to 180. Twice of angle 1 is 180. Angle 1 is equal to 90. So we proved that one angle is this angle is a right angle, so it's a rectangle. See, one triangle we have taken up is this one, children. This is that. Leave this and ignore this one. There's a triangle ADC here. There's a triangle ADC, this ADC, where this is angle 1. This full thing is angle 1. Then the other triangle is BDC. Not this one, not this one. What you see here, BDC. There, just thinking that I start coughing, I can't stop. All right. So what happens, it's scared to talk because I'm sure the minute I start talking, I'm going to get back coughing. Sorry. Yeah. Yeah, children. So I was telling you that it's about this angle equal to this angle. We have this angle. This is the angle here you see in this triangle. And this angle in this triangle. We proved that these two triangles are congruent. So CPCT, angle 1 is equal to angle 2. But what are angle 1 and 2? See, don't get confused. In this figure, don't think this is 1 and this is 2. See, this full angle is 1. This full angle is 2. And what about, so what are 1 and 2? They are adjacent angles and they are supplementary. Angle 1 plus 2 is 180, but 1 and 2 are equal. So you get 1 is 90. This angle 1 is 90. So in the parallelogram, one angle is a right angle. So it's a rectangle. So the answer to the question, how do we know like we have to take up these two triangles or how to start, lies in what we have to prove. We have to prove it's a rectangle. I think we'll start writing, children, because I can't talk after this. Yeah, children, I think I can continue. We finished this one, right? Yeah. Yeah. So here, I think 1 minute. These are quite simple. I think 2, 3 we can finish in 5 minutes. Look at this one. Diagonal AC of a parallelogram ABCD. ABCD is a parallelogram. Diagonal AC bisects angle A. Diagonal AC bisects angle A. That means the angle 1 is equal to angle 2, correct? Show that it also bisects angle C. So it should show that angle 3 is equal to angle 4. This is the diagonal AC. It is given that it bisects angle A. You must prove that it also bisects angle C. All right. Now, this is angle 1, this is angle 2. If angle 1 is equal to angle 2, prove that angle 3 is equal to angle 4. Is that fine? Now, this is easy because now is angle 1 equal to angle 4, children? Is 1 equal to 4? Why? Alternate interior angles are equal. Is angle 2 equal to angle 3? Is angle 1 equal to angle 2? Why? Because it's given that AC bisects angle A. Now look at this. 1 is equal to 4, 2 is equal to 3, but 1 and 2 are equal. 1 and 2 are equal. 1 and 2 are equal. See here. Look at, compare this. 1 is equal to 2, but you see 1 and 2 here. That means 3 is equal to 4, right? Angle 1 is equal to angle 4, alternate angles. Angle 2 is equal to angle 3, alternate angles. But 1 and 2 itself are equal. That means 3 is equal to 4. 3 is equal to 4 means AC bisects angle C. Then we'll have to prove that ABCD is a rhombus. Now, how to prove it's a rhombus? It's already a parallelogram. How do you prove a parallelogram is a rhombus? All sides should be equal. All sides should be equal. How do you prove that a parallelogram is a rhombus? All the sides should be equal. But you don't even have to prove all sides are equal. It's enough if you show. It's enough if you show adjacent sides are equal. All right. Now see, diagonals bisect each other in a parallelogram. What is the definition of a rhombus, children? A parallelogram in which all sides are equal. Use the definition. What is a rhombus? A parallelogram in which all the sides are equal. To prove all the sides are equal, you don't have to actually prove all sides are equal. Okay, 1 minute. Is side 1 equal to side 2? Is side 3 equal to side 4? Why? Because it's a parallelogram. So, side 1 is equal to side 2. Opposite sides equal. Side 3 is equal to side 4. Why? Opposite sides equal. Now, in this situation, if you prove any one pair of adjacent sides are equal, any one pair of adjacent sides, which are the adjacent sides? Side 1, side 4, side 4, side 2, side 2, side 3, side 3, side 1. You prove any one of these 4. Not all, any one you prove. Supposing you prove this 1 is equal to 4. What happens here? 1 is equal to 4. From in the equality length, this one, and from this equality, this one, if they're equal, that means all the 4 are equal. Just give some number. So supposing 1 is some 50 degrees. 4 is also 50 degrees, no? Correct. Then if 4 is 50, 3 is also 50. And if 1 is 50, 2 is also 50. So you can see all the angles are 50. I'm just giving you some. Just put some numbers, you'll understand. Or okay, but I took angle. They're actually sides. Let's give some lens now. I'm saying so side 1 is equal to side 2. Why? Opposite sides equal. Side 3 is equal to side 4. Opposite sides equal. In this situation, prove any one pair of adjacent sides are equal. Supposing you prove that 2 is equal to 4. 2 is equal to 4. 2 is equal to 4. Okay, now say 2 is 10 centimeters. Then how much is 4? 10 centimeters. But 2 and 1, they're already equal. So 1 also will be 10 centimeters. 4 and 3 already equal. So this is also 10 centimeters. So what do we see? All the sides are equal. So when opposite sides are equal, it is enough if you prove any one pair of adjacent sides are equal. Then all the sides will become equal. When already, not always, when already opposite sides are equal. If you prove any one pair of adjacent sides are equal, then all the sides are equal. Okay. So we proved the first part we proved. Angle C is bisected. Now for the next one. For the next one, is angle A equal to angle C? In a parallelogram, opposite angles are equal. Half of angle A is equal to half of angle C. Halves of equals are always equal. What is half of angle A? What is half of angle A? Angle 1. Angle 1. What is half of angle C? Angle 3. Okay, angle 3. Now, what do you see in this triangle ADC? ADC. Angle 1 is equal to angle 3. That means these two sides are equal, no? If two angles are equal, sides opposite of them are equal. So you get AD equal to DC. We proved adjacent sides are equal. AD is AD equal to DC. We proved. So that means all the sides are equal, and hence it's a rhombus. Use the definition is what I'm stressing on. To prove it's a rhombus, use the definition. A parallelogram in which all the sides are equal. It is already a parallelogram. You just have to prove all sides are equal. Already opposite sides are equal. So it is enough if you prove adjacent sides are equal. Then it is a rhombus, because when adjacent sides are equal, all the sides are now equal because already opposite sides are equal. So in a parallelogram, when all the sides are equal, it is a rhombus. So tell me quickly again. From the first one. Let me change the numbers. What is given? What is given? Angle. Which angle is equal to which angle is given? What is given? AC bisects angle A. That means correct. Use the angles and tell me which are the two angles equal. 3 is equal to 4. AC bisects angle A, no? So 3 is equal to 4 is given, right? I just changed the numbers to check if you've understood. AC bisects angle A. That means angle 3 is equal to angle 4. Correct? Okay. This is given to us. This is given. Now the proof is angle 3 is equal to. I've just changed the numbers, children. I didn't want to use the same 1, 2, 3, 4. The same position for the angles. Angle 3 is equal to angle 2. Alternate angles. Angle 4 is equal to angle 1. Alternate angles. But angle 3 is equal to angle 4. That means all the angles are equal. all the angles are equal, or angle 2 is equal to angle 1. So angle 2 is equal to angle 1 means angle 2 is equal to angle 1 means AC bisects angle C. AC bisects angle C because 2 is equal to 1. So we proved that AC bisects angle C by proving that angle 1 is equal to angle 2. All right. Now we'll have to prove that it's a rhombus. So we have to prove adjacent sides are equal. Any one pair of adjacent sides are equal. For that, what we did is we write angle A is equal to angle C. Okay. Opposite angles are equal. Half of angle A is equal to half of angle C. Half of angle A. You can write angle 3 or angle 4. Anything you can write. Half of angle A, you can write angle 4. Half of angle C, you can write. Now you should write. See, if you have written 4, then you should write 2 only. If you have written 4, you should write 2. If you have written 3, you can write 1. Now we have to write 2 only. So now in this triangle, in which triangle? In this triangle, angle 4 is equal to angle 2. Angle 4 is equal to angle 2 in this triangle. That means if two angles are equal, the sides opposite them are equal. So AB is equal to BC. Opposite sides are equal. Now we proved adjacent sides are equal, so all sides are equal. So the definition is satisfied. A parallelogram in which all the sides are equal is a rhombus. All right. Got it, children? Online children? Today it was
Yes,
very quiet from the opposite end. Yeah, thank you, Aniruddhan. Now we acknowledge. Thank you. Was it clear, all of you? Tell me.
Yes, ma'am. Clear. Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, but it was very unusually quiet. Or was it because you were constantly talking? You didn't ask us anything. I don't know. But I think I did ask. But I didn't get any answer from the the virtual students. Okay. Okay, sure, right? All of you understood? Everything clear?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay. Fine, children. I'll share the images on WhatsApp. Please complete the notes by the next class. Next class, I told you, we'll be doing circles, the numerical part of circles. So please complete this. Okay, don't forget, complete this before the next class. All right, children. Thank you. All right, online students, that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children. Thank you.